Welcome to the video lecture on operation management subject. In that, uh, I am started the forecasting technique. So this concept comes under in the operation management. The forecasting is all about estimation and predictions of the future, and also we can call it a scientifically calculated guess. Prediction means future thinking. Here we where we do the predictions of products because we are studying the operation management subject that is related to the industry. See, the forecasting we can say example of weather forecasting. The forecasting weather department they will forecast the weather every day, every hours. How to calculate weather forecasting? In that we have satellites. Okay, a barometer is used to calculate atmospheric pressure. Also, they will record the sunshine rays. Anemometer is used to calculate wind speed. Okay, they have all scientific setup. By using all, they will calculate the weather forecasting. What is the weather for the next day? Understood? So likewise, in industry, have to calculate future predictions with the help of some past data. Okay, this is nothing but forecasting technique. Okay, the forecasting is a process of making predictions of the future based on the past and present data. Okay, we have to analyze the past data to calculate the future data. Okay, this is nothing but a forecasting. Today's lecture I will discuss about the components of time series. Okay, components of time series, and uh, after that we see the next class calculate the forecast using moving average, weighted moving average, and exponential smoothing. These are the important techniques used in the industry to calculate the future data. Okay, first one we see the components of time series. The time series analysis, it may consist of determining the trend that underlying the demand that is related to the future trend. Okay, the components of time series generally you can say the next slide. Yes, a component of time series where basically you have the uh, generally classified as a trend. It indicates as a capital T. Okay, we have the cyclical elements that we call as the capital C. Seasonal that we call seasonality. Okay, it's also called as capital S. And uh, random or irregular variation in the demand rate. So depending on the seasons, there will be rate of demand will be interchanged. So for example, the winter season will start. There will be a demand of the sweaters in the market increases. So that we called as the demand of seasonality. Okay, if you see the trend, a long period tendency of demand to increase or decrease that we called as the trend. This long-term secular movement of the demand which indicates the overall growth or decline of the business over time. If you see this forecasting line, there will demand will be increase, decrease, increase, and decrease. It goes like that. Okay, this graph should be a y-axis for a time and sorry, x-axis for time and y-axis for the demand sales rate. Okay, there will be variation in the demands depending on the trends. Okay, also we have the cyclical elements. If you see cyclical elements, the variations occur when demand fluctuations above and below the trend line. Okay, this is the trend line. Okay, the fluctuation continuously occurs in the market, that we call it as the in terms of cycles. Okay, again here same, the y-axis is on the demand of the that product with respect to the time. Okay, this line in an oscillating pattern, just like a sinusoidal wave. And cyclic variations are usually associated with business cycles. The magnitude, timing, and pattern of cyclic fluctuations vary widely from product to product. Now, the best example for cyclic variation is demand for gold rate. Every day it will fluctuate. Also, the rate of petrol, diesel. So every day these rates are fluctuating in the markets. So it is called as the cyclic elements. So next we have the seasonality. Okay, seasonal variations. It takes place when the similar demand patterns occur during corresponding months of successive years. Okay, they occur regularly one more times or year, annually or repeatedly. For example, like given the sales of umbrella during monsoon, the demand is increases. Also, the best example in summer season, air conditioning or air coolers. The product of air coolers demand is increases in the summer season. Okay, with the help of seasonality, it will increase after the peak point the season goes. The demand of that product will be decreased. This is trend line. Again, it is same y-axis of the demand rate with respect to the x-axis time variations. Okay. Also, we have the irregular variations or random variations. See, when the demand fluctuations are occur without no reason, they are said to be irregular variations. They occur without any fixed pattern. Okay, irregular or random variations are variations that are not explained by trend, cyclic, or seasonal variations. Okay, the irregular variation occur as a result of with the help of some climates, natural foods, okay, earthquakes and terrorists. If you say this graph, this y-axis tells the demand in the market with respect to the x-axis time variation. Okay, with the help of, for example, here tourism industry. In peak points, the tourism will be increases. Okay. Also, the stock market index, the variation in stock market index, that also comes in the irregular variations. Okay, these are some standard components in the time series. With the help of time, the demand market, the value of the market in the demand changes. Okay, that we called as the time series. Okay. Also, if you say some standard graphs here, there will be variation in the demand, how it goes on in the trend. The data exhibits steady growth or decline over the time. So this is trend line. With the seasonal component in historical demand, with the help of seasons, how this, just I told, a sinusoidal wave formation takes place. Year to year, this demand rate changes. Also for cycle component in historical demand. With respect to the demand in the market of that product, it will be fluctuates. Okay, now we'll stop here. Again we see in the next class a remaining part, that is classification of the time series.